Hello, so we're going to try to make sure we know how to balance reactions. So first we need to count how many of each type of atom there are on each side of the arrow. So for example, here we have the synthesis of water. So we have hydrogen and oxygen. And what we're going to do is count how many of each type of atom there are on either side. So we got 2 of the hydrogen, marked by the 2 subscript. We got 2 of the oxygen with the 2 subscript, okay? And then over here, we got 2 hydrogen and 1 oxygen because there's nothing written right there. So there's only one of those, all right? Now we go to the next step. We have to check if there are any unequal atom types. Okay, let's look. Hydrogen is equal. Oxygen is unequal. So it has 2 on the left and 1 on the right. It needs to be 2 and 2 or 1 and 1, all right? So we're gonna choose one of the ones that are unequal to fix. So we need to choose, the only one that's available is this oxygen right now, okay? So to fix it, we need to decide on a coefficient that's going to make it closer or to the equal. So right now, to get this to a 2, we need to do something here with this water. So I can't change what's inside the water. I can only change what's on the outside. So instead of 1, which is what it is right now, I can make this a 2. And now that I've used a 2, I have to update my totals like it says here. Once we decide on a coefficient, we make it, and then recount the atoms you changed with a new coefficient. So the new coefficient is a 2, and we got to change our hydrogen and our oxygen. So hydrogen now becomes 4 because 2 and 2. So there's now 2 times 2 is 4. This one, 2 times 1, just changes to a 2. Okay? Now, we're going to repeat steps 2 through 5 until every type has the same on the left and right. That means that the hydrogen equals the hydrogen and the oxygen equals the oxygen, okay? Hydrogen does not need to equal oxygen. So the only thing we need to do now is make this hydrogen a 4. And the way I can do that, the only thing on the left that's hydrogen is this guy over here. And really, what times 2 makes 4? And so it's going to be a 2, which means that this becomes 4, because 2 times 2 is 4. All right, and then we've done all these other bits. So we can go back and check. Oh, they're both equal. So we're done. It's balanced. Okay, so now we have a new problem. We got zinc plus hydrochloric acid makes zinc chloride and hydrogen gas. So here, it's the decomposition of a metal. And so it's going to be, the addition of an acid with a metal makes hydrogen gas and the zinc chloride. So what we need to do is we got to follow our steps. I've shortened them down to 1 to 2 words each, okay? So what we need to do is count. So we're going to have our zinc, our hydrogen, our chlorine, and what we need to do is we need to count them. So there's no number after the zinc, so we know that's going to be a 1. No number after the hydrogen, that's going to be a 1. Chlorine, 1. The left side's pretty easy for us. On the other side, though, we got a different story. So there's still no number after the zinc. We can guess that that's a 1. There's a chlorine with a 2, so I'm going to make that a 2. Then we got a hydrogen with a 2, so that's also going to be 2. All right. Now we're going to check. Zinc, it's equal. Don't have to touch it yet. Hydrogen, not equal. Chlorine, not equal. So we're going to choose one of them. I'm just going to go in order just so that we can follow this. Okay, So let's make the hydrogen equal. I'm not going to touch the larger one. I'm going to make the smaller one up to 2. So the way I can do that is I know if I multiply this molecule by 2, come on, there we go. Now it's 2 times 1 makes 2. 2 times 1 makes 2. Okay? Then we're going to recount. So we did the recounting, and then we're going to repeat. So we got to check. Zinc still good. Hydrogen got better. Chlorine got better. And now it's balanced. Even though we only just changed the one thing, it's now balanced. Okay, so let's try this one. We have aluminum carbon mixture here with water, makes aluminum hydroxide and methane. So what we need to do is we're going to count first. All right, let's do the counting. We got aluminum, carbon, hydrogen, oxygen. Al-choo. Usually I like to go choo-choo, but it's al-choo-choo, okay? So we got 4 aluminum here. Let's make our little lines, make sure we can see the difference. So we've got 4. Then we got 1 on this side. Then we got 3 carbon. And we have 1 carbon on the right side. And then we have 2 hydrogen left. And we got 3 hydrogen here, right? Because everything inside the parentheses is times 3. But then we also have this guy over here in the methane, which is 4. So we got 3 plus 4 makes 7. All right, and then we have oxygen. Oxygen on the left. There's only 1 of those. And then there's oxygen over here, which is only 3. All right, now, after we count, we check. And it looks like none of these are equal right now. So we're going to choose one of them. We're going to let our choice be decided by the order they're in. So that's a 4. Let's go and make this a 4. Because there's only 1 aluminum in this molecule. We got to make this whole molecule times 4 to make that aluminum 4. So it's going to be 4. And now we got to recalculate. So 4 times 3 for the oxygen is 12. This is why I usually tell people you do not want to just look at the number down here and then times it by whatever you're multiplying by, because you sometimes have stuff over here as well. So we have 4 times 3 is the 12, plus another 4 makes 16. Okay. Now, our next step will be carbon. Carbon, this looks like the easier one to deal with. So we're going to make this a 3, because 3 times 1 is 3. So that becomes a 3. And then we got to recalculate with the whole hydrogen piece. So 4 times 3, 12, plus another 3 times 4 is another 12, so that's 24. Right? 4 times 3 and 3 times 4. And you're adding them. So if you're wanting to think about how you're doing this, okay, that's what's actually happening. So 12 plus 12, 24. All right, next step. So we got the carbon, we got the aluminum. See, we're backed up here, checking. Focus, there we go. Back to checking. Now I have to choose a new one. I'm gonna say it's probably gonna be this guy. It might be our last one. So either we can do oxygen or the hydrogen, doesn't matter at this point, because they're both affected by this. So either you can look at this oxygen and go, oh, I just need to make this a 12. That works. You can also look here, 24, and this is the only place where hydrogen is on the left. So 24 divided by 2 would be 12 as well. So this has to be a 12, which means the hydrogen becomes 12 times 2, 24. And the oxygen is just 12 times 1, so 12. So now we go back to checking. 4 and 4, 3 and 3, 24, 24, 12, 12. It is balanced. And I didn't have to touch this aluminum carbon thing. All right.